So last class, we we spoke about dot product, and we said it's also called the scalar product. And what exactly is that? Well, that's what we use in order to multiply vectors. So if I want to multiply two vectors, well, for your exam, you'll be required to multiply two vectors. I would find the dot product or the scalar product. And how would you do that? Well, say you're given two vectors, column vectors, right? So A is XY and B is CD. In order to find the dot product, or in order to multiply these two vectors, you would find the product of the X components, so the product of the numbers on top, plus the product of the numbers below, so the Y component. And that's it. So we went through an example last time, and we said, if you're given this question, and you have to find the dot product of A, which is given as 3, 4, and B minus 1, 6. All you need to do in order to find the dot product is find the product of the X components. So multiply the two top numbers, 3 by minus 1, plus the product of the bottom numbers, 4 by 6, and simplify. So that's minus 3 plus 24, and that will give you 21, right? That's what we did last class. That's what we ended with. But there's more, right? So the dot product not only allows us to multiply two vectors, but we can actually use it to find the angle between two vectors as well. So let me just show you. Say this is my vector A. Oops, well, let's just pretend the R is on the line. That's a vector A. And let's say this is the vector B. I can actually use the dot product to find this angle here. Let me just name it theta. Ooh, theta. So the angle between the two vectors. We can actually use the dot product to find that, right? And how exactly do we do that? Well, you apply this formula right here. The dot product is equal to the modulus of the vector A multiplied by the modulus of the vector B cosine, well, cos of the angle between them. This is the formula you would apply, right? So say you're given a question and you have to find the angle between vectors A and B again, right? So A is 3, 4, B is minus 1, 6. In order to find the angle between the vectors, you apply this formula. So the dot product is equal to the modulus of A times the modulus of B by cosine of the angle. So the first thing you would do, find the modulus or the magnitude of both vectors. So if I wanted to find the magnitude of vector A, we know we say the square root of the X component squared plus the Y component squared. So that's 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25, right? And then the square root of 25 is 5. If I wanted to find the magnitude of B, I say minus 1 squared plus 6 squared. Minus 1 squared is 1, and 6 squared is 36. So 1 plus 36, that's the square root of 37 units, right? So that's the magnitude for A and magnitude for B. But in order to find this angle, I need this magnitude, and I need the dot product. So the next thing I would find is the dot product, right? A dot B is 21. Just notice that these two angles here, these two vectors, they're the same vectors from before, right? Yeah. So that's how I know that the dot product is 21. So basically what you're doing when you want to find the angle between the vectors, you need to make sure you have the dot product and then the magnitudes of both of the vectors. And then you'll be able to apply this formula, right? So now that I have both magnitudes and the dot product, I just substitute it into this formula and I calculate the angle. So let me just clear this because there are too many things on the screen right now. So I have all that I need. I substitute it into the formula. So dot product is 21, magnitude of A is 5, magnitude of B is the square root of 37, and then cosine theta. If I rearrange this formula to make cosine theta the subject, then I'll get cosine theta is equal to 21 divided by 5 times the square root of 37. And in order to find the angle, we know that we need to find the inverse. So it's cos inverse of this value here, and you would get 46.3 degrees. Notice the angles in degrees, right? So there's no need to put your calculator in radian mode. Do you understand that?
Yes, Miss, I do.
Troy? You came in kind of late, but you understand what's going on?
Just came. Just wake up.
You said yes?
I don't.
You don't. What?
Yeah, I
Okay.
think so.
Let me just repeat it quickly.
Calculator.
Oh, you're trying to get this? Is
Yes.
that what you're trying to do? Oh, okay. So you gotta be careful with this, right? Like how you put it into the calculator. So it's cos inverse 21. So cos inverse, then you put an open bracket. 21 divided by, then you need another bracket to put 5 times the square root of 37. Close that bracket, then put another bracket, and you should get the answer. So let me just write out what you should put in the calculator, because it's really important, right? Because you could find all of this, do all of that, know exactly what to do, but because you put this right here incorrectly in your calculator, you get the wrong answer, you lose like 1 or 2 marks. So yeah, what you should put in your calculator is cos inverse. Oops, let's just pretend that looks like an S. Cos inverse, an open bracket, put the 21. Hold on. Okay, sorry. All right, what you should put in your calculator in order to find this angle here is cos inverse, put an open bracket, 21 divided by, I don't know if your calculator has this, but my own has like a fraction thingy. If you have a Casio calculator, you should just be able to, put this fraction just as it is. But if you have like a sharp or something, you might see a symbol like this to represent a fraction. Then you put an open bracket again. You put 5 times 37, close that bracket, then put another bracket to close it. But like I said, if you have a sharp calculator, you could really just put cos inverse and put the fraction as it is. 37. And you should get this answer. So this is sharp, depending on the type you have. And then this is a Casio calculator that allows you to put the fraction as it is. Are you getting this answer? Try.
Yes, miss.
You're not allowed to do that. Stop using programmable calculators. Right, you need to know this. If two vectors are perpendicular, meaning that the angle, so let me just go back here. See. Troy, this was before you came in. Hold on, what?
When I do it, it's a math error.
Math error. Tell me exactly what you put into the calculator.
Cos, shift cos open bracket 5. Or you get the R. Wait, it should be radian more, right?
No, this angle is in degrees.
All right, so shift cos open bracket 5.
5, no, not 5. It's 21 divided by 5 times root 37. So the first number you put there should be 21.
Oh, 21, then yeah. after 21, then 5 root 5 times root 37.
Yes, but you need to make sure you put that in brackets. Like if you don't have a Casio calculator, that's a, let me just show you what that looks like.
5
The
times
Casio one has like this function thing where it has like a box and then another box. So you get to put the numerator, the denominator. But I know some sharp calculators don't have that. Are you getting the answer?
Wait, let me try one more time. Keep on saying math error.
Okay. Can you
Yeah,
just send me a
math error.
pic? Can you send me a picture of what you put into the calculator in the group chat? And then you'll find the mistake there. Yeah.
Well, let me try one more time.
Okay, while you do that, I need to move on, right? But if you don't get it, send me a picture of what you put into the calculator in the group chat. So if two vectors are perpendicular, we said that the angle between them would be 90 degrees, right? Look at this, these two vectors here. When I drew them to show you that it's really the angle between the vectors we're trying to find. This is, hold on. Right. So the angle between these two vectors, that's obviously not 90 degrees, right? So I apply my formula, whatever. I got theta is 46.3. That's not 90 degrees, right? But perpendicular vectors, we know perpendicular right angle, it means 90 degrees. So my vectors would actually look like, hold on, this is giving me some trouble. Right. So let's say vector A and B again. My vector A might look like this, and then vector B going this way. So the angle between them is 90 degrees. So if two vectors are perpendicular to each other, then the dot product has to be equal to 0. And this is just, let me use like red. This right here is just a proof to show you that the dot product is really equal to 0, right? So I have my formula. I know to find the angle between, yeah, I have my formula, and when I need to find the angle between two vectors and all that, I apply this formula, right? In this case, I already know the angle. I'm trying to find the dot product. So they gave me the angle, and I'm trying to show you that the dot product will be equal to 0.
I said it.
Okay, theta is 90 degrees, right? So if I substitute that into my formula, then it will be the dot product. So A dot B is equal to the magnitude of A times the magnitude of B cosine of 90 degrees. But we know that cosine of 90 degrees from doing trigs is 0. And so the dot product is equal to the product of the modular vectors. Yes, yes it is. That's how you find the angle between two vectors. Right. Never learned that one. Yeah, that's important because like there are questions that came to the exams and you were required to know this, right? So cos 90, we know from trigs cosine or cos 90 is 0. So this right here, this second line becomes the dot product. So A dot B is equal to the modulus of A times the modulus of B multiplied by 0, because cos of 90 is 0. And anything multiplied by 0 is 0. So therefore, the dot product when two vectors are perpendicular to each other is equal to 0. Do you understand that? This is just a proof to show you that the dot product is really 0 when the angle is 90 degrees. Do you get that? No? Yes?
Yes, miss.
Repeat. Okay, if you need me to repeat anything times 0 is legit 0. It is. It is. Because it's an axiom. But you don't need to know that. That's advanced level math. Anyways. Next one. If two vectors are parallel, meaning that the angle between them is 0, right? Two parallel vectors. Then the dot product is just the product of the two magnitudes. And this, again, is just a proof to show you that, right? So I have my formula. I know that the angle between them is 0. So I substitute theta to be 0 degrees. So I have A dot B is equal to the magnitude of A times the magnitude of B cos of 0 degrees. From trigs again, we know that cos of 0 is 1. So this becomes A dot B is equal to the magnitude of A times the magnitude of B multiplied by 1. And that's why we say that when two vectors are parallel to each other, the dot product is just the product of the two magnitudes. Anything that says 1? Yes. Do you understand that?
Yes, miss.
Okay. So like I said, this in the white is really just the proof to help you understand why we say that, right? But what you're really required to know is just this. Parallel dot product is the magnitude. Product of the magnitudes. Dot product is equal to 0 when they're perpendicular. That's all you're required to know. This was just a proof to help you to understand why that's the case, right? Time to practice, of course. So I will do the first one with you, and then you get to try the others. Given two vectors, P is equal to 8i hat plus 2j hat, and Q is I hat minus 4j hat. Find part A, the dot product, so P dot Q. And then for B, they want you to find the angle between the two vectors. So just write down this question for me. Let me know when you're finished. Wait, and I'll see that question. We need to know the formula. What formula? You're talking about the dot product is equal to 0 and when the dot product is. What formula are you talking about? Resume funny. So let me just read it one more time. Given two vectors, P is equal to 8i hat plus 2j hat, and Q is equal to I hat minus 4j hat. First part, they want you to find the dot product. And then the second part, they want you to find the angle between the two vectors, right? So let's do that. This is very easy, okay? Like, please don't let it intimidate you. It's really 3 marks. So P, I hat. Remember, it's really supposed to have this little hat on top, but you can't really do that when typing. So J hat, and then Q. So when you're writing, you should put the hat here. The only reason I don't have it on the PowerPoint, and you won't see this symbol right here on your past papers, is because it's difficult to do that when typing. Can't really do that when typing. But when writing it, you should include that I hat symbol, that hat symbol there. It looks like a common P. Right. So these are my two vectors, and the first thing they want me to do is find the dot product. So we know from our formula that the dot product, let me just put input A. If I'm given two vectors, A, this is what I had on the PowerPoint, right? And B, the dot product, so A dot B is just the product of the X components, so the product of the numbers on top. So that's X times C plus the product of the Y components, so the numbers on the bottom, Y times D. That's what I have on the PowerPoint, right? Our two vectors in this case, they're P and Q. So P dot Q, which is the dot product, would be the product of the X components. And remember, the X components are like the coefficients of the Y, of the I hat symbol, right? So in this case, it's X and this number is understood to be 1. Plus the product of the y components, which would be these two numbers, or you might remember it as the coefficients of the j hat symbol. So it would be 2 multiplied by minus 4. Please remember, you have to include the sign, right? Because I've seen people too many times, they would just put 2 multiplied by 4, but no, it's minus 4, negative 4, right? Negative 4. And that's all you have to do to find the dot product. Simplify this. 8 times 1 is 8, plus 2 multiplied by minus 4 is minus 8. So 8 plus minus 8, that's going to give me 0. Everybody good with that?
Yes, miss. But miss, question. Since that is zero, like it's 0 degrees, wouldn't that mean it's a 90-degree angle? So we don't really need to solve for b.
Well, it's not 0 degrees. The dot product is 0. But yes, the second part, you could simply write, since the dot product is equal to 0, these two angles are perpendicular and the angle is 90 degrees. Like, there's no need for you to, go and put the formula and all that. You can, but there's really no need to. Just state that since the dot product is 0, the angle has to be 90 degrees.
Understood, miss. Thank you.
Yeah. Can I clear this now?
Yes, miss, you can.
All right. So because we know the dot product is 0, like I said, give them a statement. So like, since p dot q is equal to 0, then these two vectors are perpendicular and the angle between them is 90 degrees. Or if you don't feel comfortable doing that and you actually want to, apply the formula still. So remember, it's a dot b is equal to the magnitude of, let's just pretend it looks like an a, but the magnitude of b cosine of 0. So a dot b, 0. The magnitude of a, in this case, it would be p, right? So let me just replace it with p and q, just so that I don't confuse anyone. So p, q, p, q. I have my dot product already, that's 0. But I don't have the modulus of p or the modulus of q. And I need that in order to find my my angle. It should be a theta sign. So modulus of p, that would be the square root of 8 squared plus 2 squared, which is equal to the square root of 64 plus 4 square root of 68. All right, so that's the modulus of p. Q, let me just flip it to the side here. That would be the square root of 1 squared plus minus 4 squared. Yeah, that's a 2. Anyways, so this is the square root of 1 plus 16. 17. So this is the square root of 68 square root of 17 cos theta. Hold on, let me look at the chat. Okay. Let me continue. So making cos theta the subject so that we can find the angle, cos theta would be equal to 0 on the square root of 68 by the square root of 17. But of course, we know 0 divided by a number is 0. So that's cos theta is equal to 0. And then cos inverse of 0 would actually give you 90. So if you see a question like this on your exam paper, right? The first part to find the dot product, let's say that was 2 marks. And then the second part, when they asked you to find the angle, it was 1 mark. You could just write the statement since the dot product is equal to 0, they're perpendicular, so the angle is 90. But if you see like 2 marks and you're not comfortable, just writing that statement, you could show this, right? Just to make sure that you get all your marks. Okay? Everybody okay with that?
Yes, miss.
Okay. Can I clear this now?
Yes, miss.
Just like we gave this. This whole everything is just easy, I don't know why people think add math is so difficult. It's really not. Number 2, let's go. Let me just read it out. The vectors of 2 points A and B relative to the origin, to a fixed origin O are given by OA is equal to 2i hat plus j hat, and then OB is 3i hat minus 5j hat. Find the angle AOB to the nearest whole number. So let's say this is my vector. So going from O to A, let's say that's my vector OA, and then this is my vector OB. What they want you to find is this right here. So they want you to find the angle AOB. So it's basically this yellow angle right here. And all you have to do, like we just went through, to find the angle between 2 vectors, just apply the formula. What formula am I talking about? It's this one. The dot product, or the product of the 2 vectors, is equal to the magnitude of the vector, well, the product of the magnitudes of the vectors, cosine the angle between them. You need to find the dot product. You need the magnitude of this one, and then you'll be able to find the angle theta. That's it. And in this case, they ask you for the nearest whole number. So you don't put a decimal. You need to put a whole number, the nearest whole number, right? That's it. That's all you have to do. Let me know when you finish.